Okay, so for today, we are going to be doing a little bit more with exponentials. I started you on this yesterday. We'll see if you still remember it. If I started with $1,000 and I ended with $5,000 and I did it over the course of 5 years, that's a lot of growth really fast. You could solve that equation I just wrote and solve it for R. You'd be able to find what R is. Remember doing this yesterday? A little bit? All right. So your first step would have been to divide by what? 1,000. And wait, don't even do that yet. That's the starting value. What's that? Ending value. What's that? The rate. And what's that? The time. And if it's in years, then it's in years. Could something grow from 1,000 to 5,000 in a matter of days? Yes, especially if it's like bacteria or whatever. They can multiply incredibly fast. All right, so we're going to start by dividing by 1,000 on both sides. And the cool thing is this cancels and it cleans it up so much. And these zeros cancel, so it's just 5 equals 1 plus R to the 5. But then a lot of people get stumped right there. Do you know how to clear that power of 5? Yes. Put it to the 1/5. You are correct. Like this. And yes, you are going to times them, but you're putting the whole thing to the power of 1/5. Because then these get times, right? Because that's what happens when you do a power to a power. All right. You need some paper? If you don't have your iPad, I can let you borrow some of my scratch paper over here. Don't want you to just sit there and watch me. You'll remember 10%. You'd need a calculator to do this part because nobody can do 5 to the 1/5 power in their head. It's a weird decimal. And the power of is the little caret thing. So to put this in a calculator, you'd type in 5 caret parenthesis 1 divided by 5. It might work without the parentheses, but you might be putting 5 to the power of 1 and then dividing by 5, which is totally different. You want this 5 to the power of 1/5, so get used to putting in parentheses. If you put in extra parentheses in your calculator, sometimes it saves the day. It keeps your calculator from messing up. All right, you're going to get some decimal, like let's say 1.63 or something equals 1 plus R. And all you got to do at the end is subtract off the 1 because the growth rate is just the part after the 1. So it all makes sense. It wasn't 1.63 though. What was it? 1.38. If we round it, is that good enough rounding? All right. Then, once you subtract off the 1, R, which is the royalty, equals 0.38. Of course it's not the royalty. What is the R? The rate. The rate is 38%. So you need, if you got 38% growth, has there ever been a stock that's done that? Oh yeah, there is. 38% growth is not bad, but there's been, I mean, it's really good, in fact. Way better than average. But there are some stocks that have gone up way faster than 38%. So, all right. I'll give you another scenario from beginning to end without writing the equation for you. You write the equation, you solve it. So here's a moose problem. We have 4,000 moose in Minnesota, but the population's been going down. And what if a scientist figures out a moose vaccination? And the cool part is you can fire it into the moose with a gun and like a dart, you know, like one of those tranquilizer darts. Okay, well, if you tag the moose with it, they actually just get injected with this vaccine, and that'll keep them from being chomped on by these, or at least getting sick from these ticks. That's actually what's killing the moose, they think, is these little tiny ticks. They get this infested with ticks, and then they start scratching on it, and they can't get the ticks off. Can you imagine like having ticks on your back, and you have hooves, and you can't reach your back? Can you imagine how hard that would be to like I have ticks on my back? You'd be like, you'd be scratching on a wall too, trying to get them off of you. Anyway, so they scratch on trees and they're trying to get them off of them, and then they get like actually lose some of their hide, like their moose hide, you know, their hair that's gets rubbed off. And anyway, it's kind of sad. They don't have opposable thumbs, so they can't pick off their ticks. Anyway, so what if a scientist has come up with this cool way to vaccinate them so that they will not get sick from the ticks, and it'll just maybe make them like make it so the ticks don't want to chomp on them, kind of like a tick repellent. Now we have a moose problem, and it's going the other way. We go from 4,000 moose to 12,000 moose over the course of the next 10 years. The test question could say, what was the rate of growth? 4,000 to 10,000. No, 12, sorry. 4,000 to 12,000 over the next 10 years. Write an equation for it, solve it. You'll have to do a power of like 1/10 or something like that. All right, I'm going to pause while you write that one and try to solve that equation. What you're trying to find is the rate that would cause you to go from 4,000 to 12,000 over 10 years. All right, so here we go. You'd start with your 4,000 moose, sorry, and then you grow to 12,000 moose, and you do it over a period of 10 years. 1 plus the r, and I'm dividing both sides by 4,000. Yeah, I made the numbers kind of nice, so it would work kind of nice, but you know, if you would get decimals, it wouldn't be a big deal. That comes out to 3, though. 1 plus r to the 10th. Then you put both sides to the 1/10 power. Why both sides? Doesn't this side need to be fixed? But if you do it to this side, you got to do it to that side. All right, you should have done 3 to the power of 1/10. What did you get? 1.11 equals 1 plus r. Anybody verify it was 11% approximately? Would it round to 12? Okay, that's cool. I was actually thinking it felt a little low, and it would make more sense to me. All right, so 12% growth. Doesn't that also mean that at 12% growth in the bank, your money would grow from 4,000 to 12,000 over the course of 10 years? Yeah, that's what that means. It doesn't have to be moose. All right, so there's an example of one of the hardest kind. Now, we are, but the cool part about that part is that you just have a formula and you stick the things in the right place, and it's just, you know, like stick it in there and solve it. Well, how about this? This is the type for today that is going to confuse some of you. By the end of the hour, you'll be able to solve that. And what's different about it is the x is in the exponent. There's the normal way to solve this is with logs, but you don't know how to do logs yet. All right, I'm going to change this. It would be pretty much impossible to solve it except for in terms of n. I'm going to make this I'll just keep it simple and just call it an x. Okay, so if I were going to solve this, here's the key, and I'll give you a really simple one at first. If I had just said this, what would the answer be? X must be 5, right? Okay. How about now? Not nearly as easy, is it? But what could you swap out? Remember, you can always swap out things like I can take a 0.5 out and put in a half. I can put things that are equal in instead. It's called substitution. What could I pull out and then put in something else instead that would work better? Usually there's somebody who gets this. What could I pull out and replace it with something else that would work better? Yes? wait a minute, replace the 4 with a 2, except 2 is not the same as 4, so 2, you're close. Yeah, it's going to be 2x because of this, but do you get what you really did is you swapped out the 4 for a 2 squared. Isn't a 2 squared the same thing as 4? And now, here's the cool part. Look, you still have the bases the same. So now it's just that equals that. So 2x must equal 5. You get if these bases are the same, then the exponents have to be equal. So then 2x must equal 5. So x must equal 5 halves. I'm going to go back to the original problem, which was 4 to the x must equal 2 to the 5th. So how do you see if that actually worked? You have to understand fraction exponents, and that's what I get to teach you next. That 5 halves would go here because we solved it and x was 5 halves. Apparently, 4 to the 5 halves power is equal to 2 to the 5th, which is the same as 32. So what in the heck does 4 to the 5 halves mean? Watch. 4 to the 5 over 2 power is the same as 4 to the 1/2 to the 5th. That probably doesn't mean much to you unless you know what the 1/2 power means. Does anybody in this room know what it does if I put something to the 1/2 power? Yes? It is pretty much square root. Very good. Think about this. If that really means square root of 4, which is what? 2, then it's really 2 to the 5th. See what I'm saying? All right, so a fraction exponent means that's the root, and that's the power. You're learning. This is good stuff. Fraction exponents is considered a big part of this class. You have to know what fraction exponents are for your next test and for the final. And fraction exponents are on the ACT. I'm not saying they're a big part, but I have seen them there before on practice tests or on retired ACTs that have been given in the past. All right, put the phone in the backpack, please. Don't want to have that out. Thank you. So, this is the root. This is the power. So if I said, what's 27 to the 2/3 power, the roots are on the bottom, just like in plants. You know, you hold up a plant, the roots are never on top, right? The roots are on the bottom. Okay. So the roots are on the bottom. So what's the third root? What are you talking about? What is the third root of 27? 3. Because 3 times 3 times 3 makes 27. That's what a third root means, is you got 3 of them. So then, is the answer just 3 then? No. It's 3 squared, because this is the power. So this is equal to 9. I want you to prove it to yourself. Grab your calculator, type in 27 to the power of 2/3, and it better come out to 9. And I want you to see then that that means you take 27 to the 1/3 power and then square it. Just stay with me. Grab your calculator. Okay. Did you verify it? Did you type it in your calculator and it actually worked? Okay, cool. If it didn't work, you're doing something wrong on your powers. You'd go 27, caret, parenthesis 2, 3. Just help me. Somebody probably tried it without parentheses. Does it work without parentheses? Okay, good. I didn't know if it would be able to follow that order of operations or not, so I'm happy to hear that it doesn't have to have the parentheses. But I'm telling you, just to be on the safe side, I've seen it happen too many times on questions that go into the calculator and you put without the parentheses. It thinks you mean to do it in a different order. All right, so then if you got that, let's see if you can get this. 4 to the 4/2 power. Roots are on the bottom. Don't type it in the calculator. That's too easy. Do it in your head. If you want to verify that you got the right answer by checking on the calculator, you can. Raise your hand if you had 16. You're right. Now, couldn't you have just done that by saying that that's 2? And then 4 to the second is 16? Yeah, you could have. But you could have done square root of 4, which is 2, and then 2 to the 4th power is 16. But that kind of just proves that this is what's happening. These work. Fraction exponents like this work. As long as you can get the root is down the bottom. So how about this one? 125 to the 2/3 power. Don't use your calculator. Do it in your head. Raise your hand when you got it. If you've got a number that's got a 5 in it, you're doing it right, probably. It is the 3rd root of 125, which is actually what? 5. Because 5 times 5 times 5 makes 125. Is the answer 5? No, it's 5 squared, which is 25. All right. So you've learned a little something about what fraction exponents mean. Just plain old exponents, you've known what that means. If I say 8 squared, you're like, duh, that means 64. But what about 8 to the 1/2? That means actually the square root of 8. And you should be able to do that in your head now, too. So what's 8 to the 2/3? Don't say it. Think it. Put your hand when you got it. So you say, GD. 4 is correct. First answer was 2, because the 3rd root of 8 is 2. And then you square it, gives you 4. Any questions? Okay. You needed to get through that so that you could handle questions like this. 16 to the 1/2 power is equal to 2 to the x. So the first thing you do is, if you really understand what square root means, you'd say that, oh, you're saying 4 equals 2 to the x. And then, yeah, you can kind of guess and check this one and say, x must be 2. Raise your hand if you got that one right. Awesome. Could you have also said that 4 was the same as 2 squared and then gone x equals 2 that way? All right, so here's a typical harder question today. Okay, that's a lot harder. But here's the key. They both can have a base of what? 2. They both can have a base of 2. This one already has a base of 2. If you could just write this side as 2 to a power, well, and that'd be easy. I'll give you a hint. 2 to the 6th is 64. But that's not what you should put in there. 2 to the 6th isn't 1 over 64. Two to the negative 6th is 1 over 64. What? That throws in negative powers. Did you know that negative powers make something flip, turn into a fraction? All right. Do you get that 2 to the 6th would have been 64? Does that make sense to you? 2 times 2 times 2 times 2 times 2. Okay, so what about this negative? That just makes it 1 over. Do you remember when we did these just yesterday? What did that do? It made it flip, right? That's the same as a to the 1, except 1 over that. Okay, so a negative power makes it flip. What's 9 to the negative 1/2 power? Don't just say 3. It's not 3. So do it in steps. Would you agree that's the same as 9 to the 1/2 to the negative 1? Whoa, what just happened there? I just broke up negative 1/2 into this times this, right? And then why did I do that? Because I know you can do 9 to the 1/2. What's that? 3. What's 3 to the negative 1? 1/3. Okay. So, try this one. Check with the kid next to you. See if you got it. 4 to the x plus 1 is equal to 32 to the 2x minus 1. Hint, make these bases the same, and 32 isn't 4 to the something. That means both of them need to have a base change. Make both of them into base 2. 2 to the something and 2 to the something. And then you might be able to pull this one off. I'm going to pause for a second while you give that one a try. All right, so you should have said this was 2 squared. Isn't that what 4 is? Is 2 squared? But then there's still something else besides that, this part, x plus 1. And this 32, I think a lot of you probably figured out was 2 to the 5th. Raise your hand if you knew it was 2 to the 5th. Okay, good. Then that's to the power of 2x minus 1. You get we have to replace this thing with this thing, and there's still the 2x minus 1 there? All right. Now, why did we replace them with those? Because now they have the same bases as each other. And things that have the same base, their exponents have to be equal. That has to equal that. Here's a very common mistake, but try to figure out what's wrong with it. 2x plus 1 must equal 10x minus 1. It's wrong. What am I doing wrong that I don't want you to do wrong? What should be different? Yes. Nope. What do you think? 10x minus 5, and there's something else wrong. Why is it minus 5? Because this has to be times by that, and this has to be times by that. And the other one? Yep. 2 times x, 2 times the 1. That should be a 2. 2x plus 2. Don't forget to distribute that out. And now, this is kind of cool. I kind of like moments like this. You had to know so much math just to get to here. And now you should be like, oh, now it's easy. Because now I just have to solve a 2-step equation that has variables on both sides. That's actually really complicated. But that becomes the easy part now. That's why I do the top 20. Because if at this point you don't know how to solve this, then you can have all that other stuff figured out, know the hard stuff, and then get stuck on the easy stuff. The easy stuff is you got variables on both sides. You're supposed to get rid of the smaller one. You should go minus 2x on both sides. That's one of the top 20s. It's that kind of question. Variables on both sides. See if you can solve it from there. Get a final answer. And the x is like negative 2/3 or whatever. Solve it. See what you get. Did you get 7/8? Raise your hand if you did. Awesome. All right, now, let's say your life depended on it, or this was a mission to Mars where you screw this up, it's going to cost the $1 billion satellite's going to crash. How are you going to check it? If x is supposed to be 7/8, go back in original. I'm not saying you'd want to do this in every problem because it'd be a pain in the butt, but I'm just reminding you that's what we found. We found what x has to be. And that would be true. It would work. And it puts both sides to fraction exponents, but they end up working out to be equal to each other. So, all right. Let's start the homework together. I know this is a little bit tricky, but I think you'll see the first few on the homework are actually really easy. It's a homework quiz. So pull that thing up, and I'll pause for a second when we get it going. Okay, so hopefully you found this little homework quiz. The first one is laughably easy. In fact, it's almost insulting. What is it? 3. Okay, how about the next one? Well, it's okay, it's a little harder, but if the bases are the same, then this has to equal this. So you have a little equation to write. If I were you, I'd have if I were you, I'd have 2 documents open, and I would be able to 4-finger swipe between them. I would be able to 4-finger swipe over, and on your iPad you'll have boop somewhere to write, and then you'd write this: 1 minus x is equal to 4. And then I would have a simple little equation. This one isn't quite as simple as you would think. You don't just subtract 1. You subtract 1, and then you'll have negative x is equal to 3. So what does x have to be? Negative 3. All right. Moving on. Oh, this is a tough one. 3 to the x equals 9. I did a lot of the really hard ones with you, so some of these must feel really like, oh my gosh, that's so easy. Now, you can do it two ways. You can just either guess and check and go 3 to the second is 9. Oh, therefore x must be 2. Or you could say 9 could be written as 3 squared, and then the bases are the same, so the exponents must be equal. Either way, what's the answer? 2. All right. So here's one where they actually give you a teeny bit of a challenge. Who can tell me what base they could both have? A 3. The left side's already got a 3 base. The right side could be rewritten as 3 to the third. Now that the bases are the same, your exponents have to be equal. That's a little equation. You solve it. And I'm pretty sure this one's going to come out to a fraction. Doesn't it, actually? Okay, one of them soon is going to come out to a fraction. And just remember to put in your fractions as, like, say it's 4/7. Just type in 4/7. Don't try to get the weird decimal for it, because then you'll guess wrong how many decimals the teacher put in. You know what I mean? Just go with, if it's a fraction answer, just type in the two numbers with a divide by sign between them. I'll double check this one. 2x minus 1 is equal to 3. And then I'm going to add 1 to both sides. Yeah, you're right. This one doesn't come out to a fraction. And then it's just x equals 2. There's a fraction coming, though. Sure. I'll do one more for you on that harder end. And I've been asked about 10, so I'll help you with 10. I know you may not be at 10 yet, but if I were you, I'd go and write it on some on a notability doc so that you can have the help when you need it. That and that could have the same base. That's the whole title of the lesson for today, is getting the same base. So, called change of base. Do you get that that and that are kind of similar, and that one of them could get squared to make the other? So then, what should the base one be? 2/3 or 4/9? 2/3. The smaller one's always the base. We always get it to be a smaller one. Okay, so then, if this one's already right, then how do I write 4/9, which is what used to be here? I'll write it in blue and then take it out. How do I write 4/9 as 2/3? Yes? Kind of. Well, let me erase. 4/9 can be written as 2/3, but not to the 1/2. That would be square rooting it. 2/3 to the what? 2/3 squared is the same as 4/9. Let me say that again. 2/3 squared is the same as 4/9. So I've replaced 4/9 with 2/3 squared. For some reason, that's really hard for people, and I don't totally get it. 2/3 squared, you just square both the top and the bottom, and you get 4/9. Let's look at the next two. What would be a good base for those two? Always use a smaller one, so what's the good base? 5/2. So 5/2 to the x, it's already got a good base, but this 1/25, I got to fix that. What could 1/25 be? It could be a 5/2. You write it like you wish it was true, but then you got to put it to a power. 5/2 to the what? 5/2 to the third. Very good. Why is that so good? Because once the bases are the same, then this must equal that. Easy peasy once you get the bases the same. And what does this really mean? 3, 3. Well, when they're powers to powers, you should know that that means multiply. All right. This will stretch you a little bit. That's good. This is an honors class. It's supposed to stretch you a little bit. It's not like the test is tomorrow. Got some time to learn this stuff. Okay. Remember that this is set for 3 tries on the Schoology quiz. After the first try, I'll give you the answers. But it gives you the average of your scores. I didn't want to just give you the second score because it'd be too easy to just fail it on purpose the first time. see what all the answers are and copy them in there. So you get the average of your scores. So try on the first time, but if it does kind of suck, then go back, fix it with the right answers, and the average score will go up. And if you really need it to, you got a third try. Okay, that's all I got for you for today.